Computational thinking, robotics, and the maker movement are driving major changes in 21st century education. With their implementation in the classroom, students are no longer listening to the sage on the stage, they are taking an active part in the learning process. In many ways, they are defining how and what they learn. In this video series, we will discuss each of these areas and their impact on education, starting with computational thinking. Stephen Wolfram is a British-American computer scientist, physicist, and businessman. He states that computational thinking is about formulating things with enough clarity and in a systematic enough way that one can tell a computer how to do them.
The neat thing that's happened is that this tool, Wolfram Language, that we built for the world in general and for the world's most sophisticated research and development people and software engineers and so on, turns out also to be super useful for kids. In fact, it's this interesting moment of convergence when the tools that are available for kids and the tools that are available for the world's most sophisticated folk have kind of converged. And so there's this great opportunity to teach kids computational thinking.
The idea of teaching computational thinking to children started with Seymour Papert, creator of the local programming language in the late 1960s. He believed that children manipulating the computer would allow them to develop procedural thinking through programming. Why is it important for students to learn computational thinking? Rapid technological advances demand that every student be introduced to computing at some level, because daily lives of most will be heavily influenced by computing. So what does a lesson on computational thinking look like? Check out this sample lesson from code.org.
The lesson on computational thinking is intended to teach you how to take a big, difficult problem and break it down into several simpler problems. The goal of this lesson is to write a set of instructions that someone can follow to draw one of the monsters included in this lesson plan. Students will break into groups to write instructions, and then they'll switch them with another group that will have to draw the monster. Groups will write instructions using the 4 steps of computational thinking: decomposition, pattern location, abstraction, and algorithms. First, groups will decompose the task, which means make a game plan. Then, they'll look for patterns between all the monsters in the catalog. When they come across differences between the monsters, they'll abstract out or remove those details. For instance, one monster in the catalog has Vegetas eyes, and another has Spritum eyes. But they both have eyes, so we can write a line that says, this monster has blank eyes. So students will be able to write a set of instructions, called an algorithm, that lists the monster's parts with blanks for what the style should be. This is the set of instructions they'll pass to other students to recreate their very own monster.
What are some potential issues with teaching computational thinking? First, there is a disagreement on the mere definition of computational thinking. Secondly, there is the issue of how and when computational thinking should be taught to students. For instance, what should be taught to elementary students compared to high school or college students? And third, whether computational thinking should be taught as an individual subject or in a cross-curricular manner within the context of other subjects. Up next, check out how robotics is changing the world of education.